So I mentioned earlier that with regards to our trig functions, there are a couple of really important angles that we can talk about, namely pi over 4 or 45 degrees, pi over 6 or 30 degrees, and pi over 3 or 60, because first, those follow nice patterns with regards to the values of our functions, but also because these allow us to connect our trig functions directly to some nice constructions in right triangles, namely the 45, 45, 90 right triangle, which we can use to get the measures that we saw from the last section for the 6 trig functions at 45 degrees or pi over 4 in that type of relationship instead, using the 1, 1 root 2 construction. And similarly, for the 30, 60, 90 right triangle, the 1, 2, root 3 right triangle, as it were, we can use this to define the values of cosine, sine, tangent, as well as secant, cosecant, and cotangent for those special values, but we're going to focus on the main 3 here and understand that we can get the others with a bit of reciprocation. But anyway, if we want to look at cosine of 60, we're going to be taking the side length adjacent to 60 degrees, which would be 1, and dividing it by the length of the hypotenuse, 2. Similarly, for cosine of 30, we would have the adjacent side there as root 3 over the hypotenuse of 2. Then for sine, at 60 degrees, the side opposite would be root 3 over the hypotenuse of 2, while the side opposite of 30 degrees would have length 1 divided by hypotenuse length 2. So sine of 30 degrees would be 1/2. And then for tangent, looking at 60, if we go opposite of 60, we will get root 3 divided by side adjacent 1 for a total value of root 3, while at 30 we have a 1 over root 3 that simplifies down to root 3 over 3. So in total, if we want to take these and convert them to a nicer construction, we have a table like so for the relationships between sine, cosine, and tangent, along with the angles 30, 45, and 60, or if you prefer, pi over 6, pi fourths, and pi thirds. And what we can do is use this construction to solve some information about right triangles. So let's say that we want to find the length of the hypotenuse for a right triangle with side of length 10 adjacent to an angle with measure 60 degrees. Well, what we would have to do is understand that if we have a side adjacent to an angle, that means we want to work in terms of cosine of that angle 60 degrees, where we have cosine of that angle is equal to 10 adjacent divided by hypotenuse, which we're just going to call c. And then from here, we know that cosine of 60, as we have, is equal to 1/2. That's still 10 over c. So c over 2 is equal to 10, or c is equal to 20. And the last thing we're going to do here is look at how we can apply this stuff to more real-world type examples in terms of things called angles of elevation and angles of depression.